Okay guys, welcome back to one of our lessons on statistics. Today we're going to be dealing with statistics of grouped data. For the sake of time, I'm going to go through this lesson quite rapidly. It is in your best interest that you can always go back or forward dependent on the aspects that you need to know. I'm going to start off with a very simple question. The table below shows the average rainfall at a few stations. There is a table here, and the table is giving me the average rainfall, be it in millimeters, or when it comes to other questions, no matter what it may say, you will be given a table with some sort of information, and you will have to work with that information. If I go further into this question, it says, use class intervals of width 10 millimeters. Construct a less than cumulative frequency distribution of the above data and let the smallest lower limit be equal to 10 millimeters. The beauty of this type of question is we are not required to use Sturge's rule in order to get the class width because we are given a clear directive on what the class width needs to be and the lower limit. The questions for this question here says calculate the mean, the median, the modal values, the 80th percentile, and the coefficient of variation. A question like this should come out for approximately 20 marks in your examinations. But let's go through it to see how we can actually achieve those 20 marks. I'm going to start off very simple. In order to perform any of those calculations, I need to remember some formulae. Now again, this is just an introduction to the formulae. As you work with it, you will become accustomed to what each aspect of the equation means. First and foremost, we start off with the calculation of the mean x bar. X bar is equal to the sum of the frequency multiplied by the midpoint divided by n. N is the sample size. Now guys, I want you to look back up here at this notation here. This stands for sigma. Sigma, once again, is the sum of. Let's go further. Sometimes I will be asked to calculate the mode. When I'm being asked to calculate the mode, I remember it as MO, the mode, most often. The mode is equal to L. This L stands for the lower limit of the modal class. Then I come across something very interesting right over here, D1 and D2. D1 is the first difference and D2 is the second difference. Just remember that for now. As I go further, I will be able to exactly show you what D1 and D2 are. For now guys, just remember first difference and the second difference. Let's go further. To more formula. Right, oh yes, the one that I forgot was the C. Very important. C is the class width, and in this aspect we know guys the class width is equal to 10. Another equation, ME. You may have guessed this by now. ME stands for the median. But I'm rushing through and giving you a PJ formula as well as a QJ formula. In actual fact, these three formulas, I can use them to calculate exactly the same things. Why am I saying that guys? Because the median, the percentile, and the quartile. Watch this. The median is the middle value. Agreed. Quartile 2 is also the middle value. So I can actually use the formula. That is why it looks exactly the same. Because the 50th percentile is also the median value, which is also the same as Q2. Now nonetheless, I want to go ahead and show you what it means in terms of the equation. If I want to calculate the median, I know L is my lower limit, I know N is my sample size, I know C is the class width. Now I come across a capital F and a lowercase f. Some of your formulas may call this a CF, cumulative frequency. But guys, if you're going to use it as being F, I want you to remember that this frequency is not the same as that frequency. That's your starting off point. Capital F is the cumulative frequency of the class preceding. Preceding what? Preceding that class that I am dealing with. I'll come later to the classes, but remember, it's the cumulative frequency preceding. If I have to go to Pj, guys, this is given as Jn over 100. Now, J is the actual percentile that I want to calculate. Let's say they ask me to calculate the 25th percentile. So obviously, J becomes 25. And 25 over 100 is a quarter. Or if they say, calculate for me the 50th percentile. 50 over 100 is half, and the 50th percentile is at Q2. Likewise, if I go to Qj, it's Jn over 4 minus F. This Jn over 4, the value for J will be the actual value of J that they want you to calculate down here. But guys, I will go over it again to show you how to use these formulae. Alright, and remember, the last or second last equation that I want to show you is the sample standard deviation. The sample standard deviation is given by the symbol S, which is equal to the square root. Now there's a whole big mumbo jumbo under here. Formula most probably will be given to you, but let us understand what are we talking about. N is the sample size. This is the sum of fx squared, which means the sum of fx squared. This here is the sum of fx all squared. Now these two values, even though they look like the same things, they are not the same things. I'll explain again as I go to the example. And the last thing, guys, is the coefficient of variation, CV. Coefficient of variation is my standard deviation divided by the mean multiplied by 100%. Now I'm going to go back to the question, guys. If I go back to the question, the first part of it asked me to calculate the mean. Or even before I calculate the mean, I had to set up this cumulative frequency table, which was part of the question nonetheless. And I have your classes, frequency, less than cumulative frequency, the midpoint, and f of x. Now as you go further, guys, you will understand that this is more or less the same, but I will be getting all of these from the equation that I want to use. If I'm dealing with this problem, I start off with the mean. The mean, sum of fx over n, which means I need to know what is f, I need to know what is x, I need to know what is f times x, and I need to know what is the sum of that. So let's start with the classes. 10 to less than 20. And here, guys, I'm going to go a bit faster because it's a repetition of the same thing over and over again. What will be the next class? 10 to less than 20. My class width is 10, remember. So it's going to be 10 plus 20, which is 30. And obviously, sorry, 20 to less than 30. And then it's going to be 30 to less than 40. 40 to less than 50, and on and on and on until I come to the last one, which is 70 to less than 80. Now remember, guys, the numbers in actual fact are in the first class are from 10 right up to 19 because they say less than 20. This is 20 right up to 29. Now what you would normally do is you'll go up here and you'll say, this is easy, 13. You will put a tick under or a line under here. Then you'll go to another 13. It's in the first one. 20 falls in this class here. Put a line 20. And when you finish off with that, you are actually calculating from the given information what is in each class. Now I'm going to skip that step because it's a cumbersome step, but in any case I have a frequency of 2, 4, 8, and when I add up these up, I should get the total that I'm dealing with, and the total will be how many is given as the sample size. The next column that I need to fill in is the less than cumulative frequency. Ask yourself a very, very simple question. How many fall in the category that are less than 20? How many are less than 20? There are 2. Then I go to the next stage and I say, but how many are less than 30? How many are less than 30 is this 4? That's correct. But the 2 is also less than 30. So this becomes 6. How many are less than 40? All of this are less than 40. And that's where I get 14. How many are less than 50? It's all of this. By now you can see the pattern, and you will continue until you come to the less than cumulative frequency, which is ending off at 30. And remember, that is your sample size. The next aspect that I need to understand is how to get the midpoint. To get the midpoint, I follow a very, very simple equation. And the equation for the midpoint is the lower limit plus the upper limit divided by 2. So this becomes 10 plus 20 divided by 2, which is 15. 20 plus 30 is 50 divided by 2, which is 25. And as I progress, you'll see that I'm simply adding the class width until I come to the last one. Then I go to the next one, guys, which is f times x. F times x is the frequency multiplied by the midpoint. Now I'm going to highlight this for you. It's the frequency multiplied by the midpoint. 2 times 15 is 30. What about the next one? It's going to be 4 multiplied by 25. And the next one, 8 multiplied by 35. And on and on and on. The last one is 2 times 75, which is 150. Now, watch what happens. If I have to add up all of these numbers and come down here, what am I actually doing? I am getting the sum of this whole column, and that is the sum of f of x. And if I go down here, I'm actually getting the sum of f of x if I add up. And normally what you will do is you'll put in the value there, and the sum of f of x is 1300. And 1300 divided by n, and n is given as 30. And if I go down to this, guys, 1300 divided by 30, I get an answer of 43,3 millimeters. And in a nutshell, I have calculated the mean. Let's go further. What about the median? If I'm asked to calculate the median, remember, you are going to be using the formula directly. But I need to understand one thing. Median. Where does the median lie? The median frequency is at the 15 count level, which falls in a certain class. Now, what do I mean the 15 count level? My sample size is 30. Median is the middle value, agreed. The middle value of 30 is where? At 15. So all I do is I go down, even before I go to that, what if my sample size was 40? The median value will be at 20. If it was 50, the median will be at 25. So all I do to get the class, the median class, is I look at the number 15 and I go down in terms of my less than cumulative frequency. The moment that I reach a number that is equivalent to 15, or the first number that is greater than 15, that becomes my class. 2 is lower, 6 is lower, 14 is lower. There's no 15, but the next one that actually increases, or the next one that goes higher than 15 is this one here, 20, which means this becomes my median class. Median class has a lower limit, has an upper limit. Now watch this, guys. The lower limit is 40. Agreed. My sample size is 30. Forget about this. Let's go to this frequency. This is the frequency of that class. What is the frequency of this class? The frequency of this class is 6. Happy. This C is the class width. What's the class width? 10. It has been given to us. I'm worried about this one, CF, and I told you sometimes you must remember it as being F. This is the frequency, or the cumulative frequency, of the class preceding the median class. The class preceding means the class before. The cumulative frequency, this column, of the class before this. And which one is before that? The 14. Very good, guys. And what does that give me? The median, which is 41,7 millimeters. Good. Let's go to the next one, guys. The mode. Mode stands for most often. There's my formula. And now I can show you what these D's mean. Let's go to firstly the modal class. The modal class is the class as being saying most often. I go to the frequencies. Most often means the highest frequency. Which one has the highest frequency? This 8 is the highest frequency, which means this becomes my modal class. Now, if this is my modal class, this is my lower limit, that is my upper limit. Agreed? Very good. Class width is 10. Very good. Now comes this concept about the differences. D1 is the first difference. D2 is the second difference. Remember, I'm dealing with this class. The first difference, when I deal with the frequencies, guys. The first difference is that one minus that one. That's D1. And your second difference is that one minus that one. That becomes your D2. Easy to remember, guys. First difference, second difference. Lower limit is 30. That's 8 minus 4. 8 minus 4 plus 8 minus 6 multiplied by 10. And my modal value is 36.7 millimeters. Very good. The next question spoke about percentiles. The question was to calculate the 80th percentile. Now guys, again, very, very easy. Remember, to calculate the percentile, the first thing that I need to do is to find the position. Where does the 80th percentile lie? The 80th percentile, P80 position, is at where? J is 80, N is 30, over 100, which is equal to 24. So my 80th percentile lies here. Now remember, I am going to be dealing with my less than cumulative frequency. Where is this position? I need to go down here. The first number that I find that is equivalent to 24 or is greater than 24 is the one, or is the class that I'm going to be using. No, no, no. 20? No. What about 25? Yes. 25 is the first number that is higher than 24. So this becomes my position of the 80th percentile, and everything else remains the same. Look at this, guys. Lower limit is 50. J, N over 100 is this actual value over here. This J N over 100 is the same 24 that I'm dealing with here. Let's deal with this frequency first. This frequency is the 5. Happy. Class width is 10. What about this frequency? Remember, do not forget, it's the frequency or the cumulative frequency preceding, meaning coming before. Which one comes before? The 20. And if I plug in all my values in the correct place, I end up with P80 as being 58 millimeters. Sometimes in the exams, they're going to ask you for something like this. Maybe they'll ask you the mid 70%. The mid 70% range. Whenever that question comes out, this is the way I work it out. I say 70 away from 100 is 30. Half of 30 is 15. So I go 15 down and 15 up. If I go 15 up, it's at 85%. If I go 15 down, it is at 55%. I work out the 55th percentile. I work out the 85th percentile. Whatever answers I get, I subtract the 2 and I end up with the mid 80%. Likewise, guys, if they have to ask you for the mid 90%, which two percentiles will you work with? It's 10 away from 100. Half of 10 is 5. I work with the 95 and I work with the 85. Okay, I'm going to go further, guys. Sorry for taking long again. Let's go to the next stage. Okay, when I finish off with this, the next thing that I'll be dealing with is to go ahead and calculate the standard deviation. Standard deviation is given by a very, very nice formula. And this formula is standard deviation is equal to, now watch this, it's the sum of fx squared, which means in order for me to work this out, I need to know what is f times x squared. But before I find out what is f times x squared, I actually need to know what is x squared. So which means I need to put in an x squared. And oh yeah, thank you, you guessed it already. In order for me to get the sum of fx squared, I need to multiply f times x squared. So I get f times x squared. And guys, when I populate this and I add up this whole column coming down here, I end up with the sum of fx squared, 100%. Let's go for it. X squared means this squared, 15 squared, 25 squared, 35 squared, 45 squared, and on until you get 75 squared. How do I get this column here? This is the frequency, not this frequency, guys, the frequency multiplied by what? Multiplied by x squared. The frequency multiplied by x squared. 2 times 225 is 450. Next one is 4 times 625. Next one, guys, 8 times 125, and on and on and on and on. And what happens when I add this up? I end up with the sum of fx squared, which is quite a big number. Watch this, guys. Remember, when I went down here, the portion that I did not write here is the sum of x times x. If my memory serves me correct, it was 1300. And now I've got this column. All I do now is I substitute into the formula. S is equal to the sum of, what's this? What's the value there? What is n? And all I'm saying is, when I do my substitution, I end up with, oh, there's it on the top, I'm looking at the bottom. S, which is equal to sum of fx squared, is this value, minus the sum of fx squared is 1300 squared, divided by n, which is 30, over 30 minus 1, and I end up with my standard deviation of 16,21. Be very, very careful, guys, because sometimes when you are writing this, and I see this happening very, very often, people tend to make a mistake and they square the whole thing. It is not squared. It's only the numerator that has a square on it. Now, nonetheless, I've got my standard deviation. I'm happy with that. And the last thing, CV. If I want CV, coefficient of variation, it's S over the mean multiplied by 100%, which is 16,21 over 43,33 multiplied by 100, and I get a critical value, coefficient of variation of 37,4%. I say critical value, but I'll come across that under probability. All I need to do now is to interpret this answer. And to interpret the answer, the higher the CV, it means the data is relatively widely dispersed around the mean. So you are going to comment on this CV value. The higher it is, the more widely dispersed it is. This here is relatively widely dispersed. 50% is widely dispersed. Thank you very much, guys. I trust that you enjoyed that. Again, sorry for the rush because I had to get this done as soon as possible. You keep well, take care, and watch all future videos. Goodbye.